Another fluid principle that you probably have experience with is that of Archimedes' principle. Archimedes' principle states that an object that's submerged in a fluid experiences a buoyant force. A buoyant force is the upward force of any object in any fluid. So if you've ever been swimming, right, and you realize that you can float on water, that is a buoyant force. It's a force that is pushing you up in the fluid that you are in. So if you have an object that is submerged, for instance, the buoyant force of the object is pushing upward and the weight of the object is pulling down. How this object behaves depends on the relationship to the buoyant force to that of the weight. If the buoyant force is greater than the weight of the object will rise to the surface and the object, we say, floats. If the buoyant force is not as strong as the weight of the object, the weight wins out and the object sinks. If the buoyant force and the weight of the object balance, we call that neutral buoyancy, and the object floats. So if you've ever been scuba diving, you can actually, sometimes they have belts that allow you to adjust the amount of air in your belt to achieve what's called a neutral buoyancy. So you're not constantly floating to the surface trying to swim downward to prevent that from happening, or swimming upward to prevent yourself from sinking. Now, the buoyant force is the weight of the displaced fluid. By displaced fluid, I mean when you place an object in the fluid, that object is taking up space the fluid used to take up. So since the buoyant force is equal to the weight of the displaced fluid, it's equal to the mass of the displaced fluid times the acceleration due to gravity. Now, often you're not given directly what the mass of the displaced fluid is, but what you are given is the density of the fluid, right? Am I floating in water? Am I floating in salt water? Am I floating in olive oil? Am I floating in liquid mercury? What is the density of the fluid? What is the volume of the object? How much volume of water am I displacing? And the acceleration due to gravity. And this relationship just comes from the fact that density is mass over volume. So mass is density times volume. I just made that substitution here. So to find the buoyant force, you need to know what the volume of the object is. You need to know what the density of the fluid you're floating in is, or you're submerged in is, and the acceleration due to gravity. This is for a submerged object. When an object is floating, take a ship, a cargo ship, for instance. When an object is floating, the buoyant force and the weight have to balance, right? For a ship floating in the water, the buoyant force upward on this ship, F sub B, has to be equal to the weight downwards. Because otherwise you'll get y acceleration. Otherwise the ship will fly up or sink down. So for a ship to float, for any object to float, those two forces have to be the same. But remember, the buoyant force is dependent upon these three things. Well, acceleration due to gravity can't change. That's the acceleration due to Earth's gravitational pull, and over the surface of the Earth, over all bodies of water, it's about 9.8 meters per second squared. The density of the fluid doesn't change. The fluid that you're floating in doesn't change. The only thing that changes is the volume of displaced liquid. So it's not the volume of the object anymore, like it was with this green circle. It's the volume of the fluid that's displaced. So a ship will displace water, in this case if it's floating in water, the weight of that water equal to the weight of the ship. So a cargo ship that's fully loaded will sink lower in the water than a cargo ship that's empty. Now, if you want to know the fraction of a cargo ship that's submerged, or icebergs, you might have learned from, about the Titanic disaster, about 10% of an iceberg is above the water, 90% of an iceberg is below the water. Well, you can use that fraction to actually determine the density difference between water and ice. Ice is less dense than water. That's why ice floats. It's one of the few liquids, it's one of the few materials to actually do that. Almost always the solid version of a material is denser than the liquid version of that material, with the exception of water. Water is densest at 4 degrees centigrade, 4 degrees Celsius. That's the densest water can be. And then as water goes warmer than that, the density drops. And as water gets colder than that, the density drops. So if you want to know the fraction submerged of an object, it's the density of that object, or rather the average density of that object, again, we're worried about averages, over the density of the fluid. So the reason you float in water, typically most people float, is because your density is smaller than the density of water. And the density of water is about 1,000 kilograms per meter cubed. Now, very, very few people, actually very elite athletes with very low body fat, can actually have an average density slightly higher than that of water, because muscle tissue and bone is slightly higher than that of water, and can actually sink in water. But the vast majority of us float. And then there's a term, again, in chemistry class you might be familiar with, specific gravity. That's just the average density of your object compared to that of water. Similar to fraction submerged, but here's just the density of the fluid that you're in, not necessarily water. Specific gravity is almost always comparing the density of an object to that of water.